चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. इन द प्रीवियस वीडियो वी saw how to extend the IGP database or two different IGP domain using a BGP link state address family, and we also check how PCE and how PCC interact with each other, and we also validated the controller on both of the controller link state database and how the controller has end-to-end view of the topology. In this lab, we will see how we can onboard the customer, how we can onboard the customer with the help of automation. We'll use the Ansible Playbook to onboard the customer. Playbook, what we'll do while receiving this triple two dot triple two dot triple two dot triple two from this RR1 to this PE1 in the in direction, we'll apply the route policy. Under the route policy, we will set the extended community color 100, BGP extended community color 100 we will attach with the help of Ansible Playbook. In the second playbook, what we'll do in the second way, we will define the policy on the controller on the PCE on this RR. This is the our PCE controller for this domain for the color 100, and for the PCC for the client 1.1.1.1. So that will achieve with the help of Ansible second playbook. Here I've also taken the output of BGP link state database from this RR. So I've run the command show BGP link state neighbor, and this RR neighbor IP and route. What are the routes I'm getting in the link state address family on this RR from this RR2? So here we can see that they are the different type of routes we are getting. So we have in a major three flags here. E flag represent to the link prefix, and V flag represent to the node, and T flag represent to the IP prefix. Let's see. We have this V flag. So this represent this is the node. So we have a three node 1, 2, 3. So we have a 1, 2, 3 node in this core domain ISS core domain 2. And V flag is representing the node, and the let's say E flag. E flag represent the link prefix. Okay, like we have this link we have configured the /30 IP that is representing. So how many link we have? For this node we have a one link. Okay, for this node we have a one two link, and for this node we have a one more link, three link. And so here we can count this if like 1 2 3 4. So four link we have and one this E flag link is coming from the BGP, as we are running the eBGP on this link, and this link is not a part of ISI, so it's representing with the BGP. So this 1 2 3 4 links and one BGP link which is not a part of ISI. And after that we have a T flag. T flag represent the IP prefixes. So these are the /30 IP node interface IP representing 1 2, and this is the loopback IP. This is again interface IP. This is again loopback. So we have a 1 2 3/32, 3 loopback for three routers, and 1 2 3 and 4. So these are the 4/30 means two subnode of the /30 1 1 1, and before that these are the net ID of the ISI. So this is how database look like while we check database on the controller. So while we jumping for the Ansible playbook to onboard the customer and to define that segmented traffic engineering policy on the controller. As of now, we have only done the segmented traffic engineering configuration on the PCC on the PE1 and PE2. These are the configuration done. Under the segment routing traffic engineering context, we have defined the PCC, our source address. This is the PE1 source address, and this is the controller address 11.11.11, which is RR1 for this PC for this client. This is the controller, and similar way on this PE2 source address will be changed to the 2222. So 2.2.2.2 is the PE2 which is acting as a client, and for this ISS core domain we have this controller. This control IP address is 33, so that will become the PCE address 33.33.33. Let's jump to the playbook. Once I will go to the playbook, onboard customer playbook, and here this is the host. On this PE1 we will do the all of the tasks, and this is the var prompt module which will get the user input while we run the playbook. We have to pass this input, We need to pass what is the extended community color number we want to use, what is the RPL name we want to define, and what is the customer prefix. What will be the customer prefix? Once we'll pass the three input, after that this playbook will do this playbook will configure the first thing extended community set. After that this will configure the RPL. This is the config line required to configure the RPL, and after that this will call the RPL in the BGP on the PE1 with respect to RR1 neighbor in the indirection. So let's run this playbook. Sudo Ansible dash playbook onboard. Let me do the verbose here. We pass on the admin credential. So here it's asking the extended color number. Let's put the color number is 200. RPL name, let's say red. Prefix our triple two dot triple two dot triple two. This is the prefix belong to BRF blue. Okay, let's wait to complete this playbook. Now it's configuring the extended community. Now it's configure the RPL on the PE. RPL is also done. Now it's calling the RPL in the BGP in the indirection toward the. So this is the configuration is done. So let me show you that this is the configuration here is done in this task in the router BGP. This is the neighbor address of router selector under the address family. Okay, this is called this route policy read in this task, and in this task is created under the route policy read digital line put if destination in this, then set the extended community color red. In the first task it has created the extended community set. Extended community set color is defined at 200. Okay, so let's go to the second playbook for the controller. This is the playbook we have to configure the segment routing 3E for the color 200 on the controller on the PCE path computation element. So description we can avoid. This is the one description put in there. So here this is the host on the RR, as RR is also acting as a PCE path computation element controller. So we are doing the config on the PC for the color 200 in the IOS-XR config module you're using in Ansible. These are the line under the PC path computation element segment of the traffic engineering section. We are configuring the peer IP. So this is the IP address of our PC PE1, as the PE1 is acting as a client. So we are putting the client IP. After that, we are defining a policy to the PE. This I given the name to the policy, and after this is the color, and this is the endpoint from where this policy. So this is this triple two dot triple two dot route for this we have set in the color. This will come from the PE2. This is the PE2 loopback. After that, again we are going the segment of traffic engineering peer. In the policy section, we define the candidate path preference and dynamic and using the metric type IGP. And after that, we're doing the verification of the LSP. What is the LSP from the PCE to the PCC? So we will run these commands show PC LSP summary. What are the LSP summary? This controller has sent to the client, and what are the LSP are sent to the particular this client, particular PE1. Let's run this playbook. Sudo Ansible dash playbook please. Not done that, sorry. Let me run this verbose. It's doing the config on the PC for the color 200. It's done the config. Now it's the verification. So we go in the one task, the one change one. Second task was the only for the show commands. So here we got the output. First output is there was two command run. One is the show PC LSP summary. So how many LSP we have? So three LSP are up and administrative also up. Total LSP are three for this peer 1.1. This is the piece. This is the provider edge one router, and this is the tunnel database. So we are interested in the color 200. This is was the color 100. Let's check what this is the color 10, and here we go. So this is the color 200. T is defined. This controller is sending this label stack to the client. So these are the seed value it's sending. It's sending to reach from the PE1 to PE2 to the prefix 222.222.222, which is connected behind the PE2. These are the label stack need to be pushed on the packet. First packet have to go to the 16,022. This is the node seed and prefix seed for the ASPR, and this is the EP egress pinning label with the link connected between the ASBR1 to ASBR2, and this is the final node PE2 node seed. So let's jump to the PE1 for the verification. So here we are on the PE1. Let's verify the configuration we have pushed from the Ansible Playbook. So let me show you the first RPL route policy. So this is the route policy we have defined, and this is the community set we have defined. And after that, this policy we have attached in the router BGP toward the RR neighbor. So here we have called this route policy. Let's see if we are getting a segment routing PE policy from the PCE. So this is the color 200. This is the policy, and this policy came up from the last 2 minutes. And preferences piece of this policy we are getting from the controller. And this is the node seed and prefix seed. This is a label stack we are getting, and this is the binding seed. Let's do the trace route now. Trace route we are at blue triple two dot triple two dot triple two dot triple two slash 32 source triple one triple one dot triple one dot sorry the slash 32. We have an reachability is following the label stack which is pushed by the controller to this client. And one more thing I want to show here is what is the configuration we are doing for the segment routing after we integrate it with the controller. Nothing else. Can only define the PC controller IP and our source address. That's it. This is the only configuration required. We can think like this way. Uh, let's suppose we have a different type of customer. For the different type of customer, operator want to provide the different treatment, like when the gold customer, silver customer, correct? So we can define the, like for the gold customer we use the 100 color, for the silver customer we go the 200 color, and for the other customer we can define the 300 color. And based on the color, sorry, we can define the policy in the segment routing T on the controller. So automatically we there is no need to define the tunnel on the each P. We need to just define the tunnel policy on the controller, and controller will take care about this. Thank you.